Welcome to Introduction to Data Analysis and Visualization with Power BI, where our goal will be to make the data visualization experience easy to learn for people from every walks of life. Meet our team of instructors who have created and designed this course. Together, we have close to 25 years of experience in practical implementation of technology and teaching technical courses at a university level. Our team members have specialization in areas of information technology, software engineering, data science, and data visualization. We will have a total of 6 modules that are designed to help the student learn progressively. We will start from the basic introduction of the course and gradually move to the intermediate concept. By the end of these lessons, you will be able to make your own reports and dashboards and manipulate data. Key concepts will be explained visually for our students so they can learn effectively. Power BI is a business analytics service by Microsoft. It aims to provide interactive visualizations and business intelligence capabilities with an interface simple enough for end users to create their own reports and dashboards. Our capstone project will help you understand the overall steps which should be followed in order to achieve the desired dashboards, implementing all the concepts taught in this course. Here are some of the companies requiring data analyst skills to fuel their day-to-day operations and critical software development needs. Hi everyone and welcome to the first lecture of our course. Before we jump directly onto Power BI, let's just get to the basic understanding of data visualization and data analytics. What comes to your mind when someone mentions data visualization? Correct. Charts and graphs is the first thing that we all think of when we talk about data visualization. The left brain allows us to focus on logic, numbers, language, whereas the right brain is more into symbol, image, and colors. Through data visualization, both left and right brain collaborate and we get an accessible way to see and understand trends, outliers, and patterns in data using visual elements like charts, graphs, and maps. Now let's dive into data analytics. Data analysis is a process of inspecting, cleansing, transforming, and modeling data with the goal of discovering useful information, informing conclusions, and supporting decision-making. I know both of these seem like interchangeable names for one thing, but they are not. So, how about we enlighten ourselves with the difference amongst them? Data visualization is nothing but representing data in a visual form. This visual form can be a chart, graphs, list, or a map, etc. This representation helps people to understand the magnitude of the data. Data analytics is the method of examining data sets, structured or unstructured, in order to get to useful insights to draw conclusions about the data sets. Data analytics techniques and technologies are widely used in many organizations. After we have built a basic foundation of the purpose of Power BI, now let's see what it is and how is it of meaning and help to us. Power BI is a business analytics service by Microsoft. It aims to provide interactive visualization and business intelligence capabilities, with an interface simple enough for end users to create their own reports and dashboards. The data used for creating visualizations is imported from multiple data sources to Power BI tools. It is developed by Microsoft and its initial release was in 2014. Power BI bridges the gap between data and decision making. This is achieved by focusing on 3 key points. Firstly, data made visual. Second, insights at scale. Third, strategic and actionable decisions. How about we discuss these a bit more? Easily connect to, model, and visualize your data, creating memorable reports personalized with your KPIs and brand. Get fast AI-powered answers to your business questions even when asking with conversational language. Make the most of your big data investments by connecting to all your data sources with the scale to analyze, share, and promote insights across your organization while maintaining data accuracy, consistency, and security. Work together easily on the same data, collaborate on reports, and share insights across popular Microsoft Office applications such as Microsoft Teams and Excel, empowering everyone in your organization to quickly make data-driven decisions that drive strategic actions. The basic workflow of Power BI involves collection of data from multiple on-site or cloud sources. Second, this data is ingested into Power BI desktop. The data is then transformed and manipulated according to user requirements. Published to the Power BI service where you can create new visualizations or build dashboards. Gateway creates the connection between Power BI cloud-based data analysis technology and the data source located on premises. And lastly, share your dashboards with others, especially people who are on the go. Hello everyone, in today's lecture we are going to discuss why do we need Power BI. As per Gartner, Power BI is a leading tool and a visionary and has been for the last 13 years. So they are saying that by 2020, augmented analytics, a paradigm that includes natural language query innovation, augmented data preparation, automated advanced analytics, and visual-based data discovery capabilities will be dominant driver of the new purchase of business intelligence analytics and data science and machine learning platform and of embedded analytics. How do you know whether Microsoft Power BI is right for your organization? A quick start. You will be able to get insights quickly with an uncomplicated setup, no required training, and included dashboards for services such as Salesforce, Google Analytics, and Microsoft Dynamics. Streamlined publication and distribution. Instead of emailing large files or putting them on a shared drive, analysts upload reports and visualizations to Power BI. Real-time information. Dashboards update in real time as data is pushed or streamed in, which gives viewers the ability to solve problems and identify opportunities quickly. Ability to customize Power BI app navigation. An app navigation experiences feature gives reports developers the power to customize navigate to help viewers find content quickly and understand the relationships between different reports and dashboards. Cortana integration. Power BI works with the Microsoft's digital assistants. Artificial intelligence. Power BI users can access image recognition and text analytics, create machine learning models, and integrate with Azure machine learning. Few valued competences of Microsoft Power BI tools. Integrate seamlessly with existing applications. Power BI integrates easily with your existing business environment, allowing you to adopt analytics and reporting capabilities. Rich personalized dashboards. The crowning feature of Microsoft Power BI is the information dashboards, which can be customized to meet the exact needs of an enterprise. Publish reports securely. The tool helps you to set up automatic data refresh and publish reports, allowing all the users to avail the latest information. No memory and speed constraints. Shifting an existing BI system to powerful cloud environment with Power BI embedded eliminates memory and speed constraints, ensuring data is quickly retrievable and analyzed. No specialized technical support required. Power BI provides agile inquiry and analysis without the need for specialized technical support. Extracting business intelligence rapidly and accurately, it helps in transforming your enterprise data into rich visuals, thus extracting business intelligence for enhanced decision-making. Balanced simplicity and performance. The in-memory analysis technology and DAX scripting language are both exquisite examples of a balance between simplicity and performance. Supports advanced data services. Microsoft Power BI development teams can help integrate the environment seamlessly with advanced cloud services like cognitive services, Cortana, or Bot framework. Tableau versus Power BI in terms of visualization. Tableau provides a bigger set of visualization than Power BI, comparatively lesser number of visualizations provided as part of Power BI. Environment. Tableau runs on both Windows and Macintosh OS. Power BI is designed to work only on Windows platform. Graphic features. Tableau provides a bigger range of charts, bars, and graphs for pictorially depicting the data available underneath. Microsoft's Power BI provides a limited set of charts, bars, and graphs compared to Tableau. Data support offline. Tableau software is to be able to provide a provision to analyze data going offline where there is no requirement for internet connectivity. This is not the case with Power BI as it does not support analyzing data going offline. In this video, we're going to discuss the Power BI product family to get a better understanding of what more does Power BI has to offer. These are handful versions of Power BI to choose from, depending on your budget, your needs, and how you want to deploy it. These versions range from light use to comprehensive features, free to premium, so users can select the one that best meets their requirements. You can opt for a Windows desktop application called Power BI Desktop, an online SaaS service called Power BI Service, a mobile Power BI app available on iOS and Android phones and tablets, or an on-premise version known as Power BI Report Server. There's also a white label service for software developers. We are going to discuss Power BI products starting from Power BI Desktop. Power BI Desktop, also known as Power BI Free. Power BI Desktop is a free desktop application you can install right on your own computer. Power BI Desktop works cohesively with the Power BI service by providing advanced data exploration, shaping, modeling, and report creation with highly interactive visualizations. You can save your work to a file and publish your data and reports right to your Power BI site to share with others. We will look into it in more detail as most of our learning revolves around this product. Second product up for discussion is Power BI Mobile. Power BI Mobile is unsurprisingly Power BI's native mobile app and is also available for Windows, iOS, and Android devices. Through the app, users can get secure access to real-time dashboards and reports, whether that data is stored in the cloud or on-premises in SQL Server. Mobile users can also create and share reports, submit natural language queries, and set up push notifications to get personal data alerts sent to their devices. Power BI Service, usually known simply as Power BI, is the full version of Power BI and is hosted on Azure, Microsoft's cloud platform. There are two ways to license Power BI Service: Power BI Pro and Power BI Premium. The Microsoft Power BI Service, sometimes referred to as a Power BI Online, is a SaaS part of Power BI. In the Power BI Service, dashboards help you keep a finger on the pulse of your business. Dashboards display tiles, which you can select to open reports for exploring further. Dashboards and reports connect to datasets that bring all of the relevant data together in one place. Power BI Pro isn't hugely different to Power BI Desktop. They have the same visualization options, the same limits of storage and file upload size, and the same report refresh allowance. The key difference is that with Pro, you can share your data, reports, and dashboards with others privately, provided they also have a Power BI Pro license. there are a few other extras that come with Pro license too. For example, with Pro you can create app workspaces where you can put together collections of related dashboards and reports and create easily accessible content packs. Power BI Premium is intended for enterprise-level businesses that generate huge amounts of data and require extensive access to the app. Shelling out for Premium means you get a dedicated portion of capacity to process your Power BI workload with all the necessary infrastructure supplied and supported by Microsoft. There are a few other features exclusive to Premium too, such as the ability to store BI assets on premises using Power BI Report Server. More on a report server later. Up to 100 terabyte of data storage and a 50 GB cap on dataset size. Power BI Report Server is an on-premises server product that ships with Power BI Premium. Report Server allows users to take advantage of Power BI on-premise. For some businesses, uploading their data to the cloud isn't an option. This could be because there are data regulation laws applying to their particular industry. Or maybe they don't have the necessary infrastructure or connectivity where they are able to be reliably access SaaS platforms. Power BI Report Server can be deployed behind a firewall and is compatible with Power BI in the cloud so that businesses have the freedom to move a cloud-based version of Power BI when they're ready. Lastly, Power BI Embedded. Power BI Embedded allows independent software vendors and developers to embed the functionality and capabilities of Power BI into their own apps on a pay-as-you-go white label basis. So rather than building their own reporting features, they can simply add Power BI into their product and Power BI will take care of all the reporting and data analysis needed. End users of the app won't even know that the app's analytics are powered by Power BI. It will just look like part of that app. Hello everyone. So as promised, we are going to dive deeper into Power BI Desktop. The most common uses for Power BI Desktop are as following. Number 1, connect to data. 2, transform and clean that data to create a data model. 3, create visuals such as charts or graphs that provide visual representations of the data. 4, create reports that are collections of visuals on one or more report pages. And lastly, share reports with others by using Power BI service. So what do you get with Power BI Desktop? Just like paid versions of Power BI, Desktop allows you to connect to data sources to Power BI with no limits or restrictions other than the total amount of data you can feed in and how much you can upload at a time. Desktop users get 10 GB of total storage in the Power BI cloud and can upload data 1 GB at a time. In Power BI Desktop, you can clean and transform data using the built-in Power Query Editor. With Power Query Editor, you make changes to your data such as changing a data type, removing columns, or combining data from multiple sources. It's like sculpting. You start with a large block of clay or data, then shave off pieces or add others as needed until the shape of the data is how you want it. After you have a data model, you can drag fields onto the report canvas to create visuals. A visual is a graphic representation of data in your model. There are many different types of visuals to choose from in Power BI Desktop. More often, you'll want to create a collection of visuals that show various aspects of the data you have used to create your model in Power BI Desktop. A collection of visuals in one Power BI Desktop file is called a report. A report can have one or more pages, just like an Excel file can have one or more worksheets. After a report is ready to share with others, you can publish the report to Power BI service and make it available to anyone in your organization who has a Power BI license. When teams work together, they need access to the same documents so they can collaborate easily. In Power BI Workspace, teams share the ownership and management of their dashboards, reports, datasets, and workbooks. Sometimes Power BI users organize their workspace based on organizational structures, or they create them from specific projects. Still, other organizations use several workspaces to store different versions of reports or dashboards they use. Hello, today we are going to discuss what Power BI Service is and what are its features. The Microsoft Power BI Service, sometimes referred to as Power BI Online, is the SaaS part of Power BI. In the Power BI Service, dashboards help you keep a finger on the pulse of your business. Dashboards display tiles which you can select to open reports for exploring further. Here are journal workflows of Power BI Service. Number 1. From your local DB, publish blank application to Power BI Service. Number 2. Load the data. Number 3. Publish it back to cloud. And lastly, share the dashboard with your colleagues. Secure live connection. With Power BI Service, you can keep your data anywhere and have secure live connection to your data through Azure Service Bus. Also access and refresh your data via direct query to cloud and on-premises data sources, live connectivity to analysis services, import with scheduled refresh, and REST APIs to stream data. Centralized data access with on-premises gateway. With centralized data access, IT can centrally manage access control to data sources. IT can audit and monitor usage, supports live interactive query to on-premises data sources and scheduled refresh, one gateway for multiple cloud services and experiences. The services which are supported includes Power BI, Power BI apps, Microsoft Flow, and Azure Logic apps. What matters the most is creation of dashboards. Build dashboards to monitor your most important business metrics. Combine on-premises and cloud data in a single pane of glass. Data is visualized as tiles that you can resize, move, rename, pin, delete, or add a hyperlink. Choose different data views. Set your featured and favorite dashboards to what you visit the most. Customize with images, videos, web code, text boxes, and color schemes. Automatic generation of data insights. Power BI Service lets you automatically generate visualizations based on your data, helps you build dashboards quickly, let you find insights in your data that you may have missed with the help of advanced algorithms that it is built on. Share your work and collaborate with others. Colleagues in and out of your organization can interact with view dashboards and associated reports, control resharing of dashboards. Everyone in group can view and edit dashboards and reports. Members can be restricted to view only. Any users with access to app can view and create personalized copies of dashboards and reports, publish to app library to share with entire organization of groups. Embed interactive visuals into company websites and apps. Hi everyone, before we can start visualizing our data, we need to import the data that we want to visualize. So let's just learn to do that first. Data ingestion. Data ingestion is the transportation of data from assorted sources to a storage medium where it can be accessed, used, and analyzed by an organization. The destination is typically a data warehouse, data mart, database, or a document store. Sources may be almost anything, including SaaS data, in-house apps, databases, spreadsheets, or even information scraped from the internet. Power BI offers many ways to pull in data for analysis, but what approaches should your organization take? The answer depends on the considerations that include whether or not your organization has an existing data warehouse, your need for real-time dashboarding, and the ease of use factor for your analysts. We explore 4 options outlining the pros and cons of each. Some data storage sources support live queries from the data warehouse to the data store. With this capability, the data warehouse is a modeling and security layer, but queries still execute on the underlying database. This can mean always fresh data, but also risk impacting live operational system performance. Data warehouses are also capable of caching and pre-processing data to lessen that operational impact and improve query performance. If your organization does not have a data warehouse setup, users can connect directly to the several operational system databases for the information they need. Live queries will be run against the data source using the direct query data connectivity mode. The next approach is for the data to be extracted from an operational system, then imported into Power BI. There are 2 main ways this can happen. The very first one being that the operational system has data exports that a user runs manually. The resulting structured text file can be manually imported into Power BI using a file data connection. This process remains manual and is primarily used for one-off ad hoc analysis. The other option is that the operational system database or online service API can be connected to by a user with access. When setting up the connection, the user selects the Import Data Connectivity mode. Data flows work like data warehouse approach, but instead they use a managed Azure data lake for storage and map data to a predefined data schema to unlock insights more quickly. Power BI supports different methods for connecting data. That is why the decision to choose the right method is always a tough decision. Data import. This method has 2 names. Some call it import data, some call it scheduled refresh. With this method, data from the source will be loaded into Power BI. Loading in Power BI means consuming memory and disk space. Indirect query is a direct connection to data source. Data will not be stored in Power BI model. And lastly, live connection. Live connection is very similar to direct query in the way that it works with the data source. It will not store the data in Power BI and it will query data source every time. However, it is different from direct query. Live connection is only supported for these datasets. First, SQL Server Analysis Services Tabular. Second, SQL Server Analysis Services Multidimensional. And lastly, Power BI Service. Hi guys, in this lecture we are going to see how we can import data from a CSV file into Power BI Desktop. But first, let's just see what is a CSV file. Comma-separated value files, often known as a CSV, are simple text files with rows of data where each value is separated by a comma. These types of files can contain very large amounts of data within a relatively small file size, making them an ideal data source for Power BI. How to connect to a CSV file? These are the steps for connecting to the CSV file. The very first being click Get Data option in the navigation pane. The second is we click the Files option and locate our file and load it into Power BI Desktop. We will shortly practically see all of these steps in our lab session. Hello guys, in this video we're going to see how can we import or read data from a CSV file to Power BI desktop. Here you can see that I have Power BI desktop interface open right in front of me. So in order to get the data from a CSV file, we need to click on this Get Data option. A single click would do. It will take a little time in order to load, but okay, so here we have another dialog box. Now you see that it has different options from which we can import our data. So since I need a CSV file to connect to, I'm going to click on this option and I'm going to click Connect. Next, you see that it has given me this browser and it's asking me from where do you want your file to open or to connect to. So my file is in downloads and this is an Annual Enterprise Survey. I'm just clicking this and now I'm clicking open. So it's connecting to the file. And yes, so this is the entire data that was in my CSV file and it's saying that the delimiter for that is a comma. This is the origin of the file and the data type base detection. So you can see that it is based on the first 200 rows. So all of this data is the first 200 rows of my CSV file. Now in order to load it, I'll just click on this load button. And it will take a little bit of time to load it. It's loading. So now you can see that this Annual Enterprise Survey file has been loaded or imported, and you can see that the storage mode is import when I hover over this option. Yes, so you can see that the last refresh over here, you can see the storage mode and the name of the file, and these are all of the tables. So we'll see that how we can explore that in the further lectures that are to come. But that's it for now. Thank you. Hi everyone, let's just see how we can import data from Excel into Power BI desktop. .xlsx or Excel format is one of the common formats which we also use in our daily lives. This format is easier to understand because of its format styled in table form. Power BI supports importing or connecting to workbooks created in Excel 2007 and later. Workbooks must be saved as .xlsx or .xlsm file type and be under 1 GB. How to connect to an Excel file using Power BI desktop. The first step is to click Get Data option in the navigation pane and then click Files option. After that, locate your file. Select Import or Connect if the workbook is saved on OneDrive or SharePoint. In the figure, you can see both the Import and Connect option. We will continue doing this in our lab session. Hello and back again. So in this video, we're going to see that how can we import the data from an Excel file. Now, similar to the CSV file, you see that we click on the Get Data option and it will take a second to load. And here is our box. So you see we have multiple options. Previously we clicked on CSV, but for the Excel you click on that option, or as a matter of fact, if you want to import the data from an XML, from a JSON file or anything, you just click on that particular option and you connect to it. So for this, I'm going to click on Excel and I'm going to connect to it. Now it's asking me what data do I want to import from. So this is my sample data Excel file and I'm going to simply open it, and it's now going to connect to this Excel file. It will take about a little bit of time in order to make the connection. And now this is our navigator. So these are multiple sheets in this data. So you see that table 1 is one sheet, that is the tab which appears below the Excel sheet, and instructions is another sheet, so is my links. So it's asking me which of the 5 do you want to load. So for instance, I want to load my table 1, so I'll click on it and simply I'll click load, and this will do the trick. So it's loading the data, it's processing my query, and it's loading this table sheet, and now you can see that this is my data from an Excel file that has been loaded into my Power BI desktop. Thank you for watching. Up next, we're going to see how we can connect to a web. Moving on, we are going to see how we can import data from web for visualization. To import the data, in the Power BI desktop Home ribbon tab, drop down the arrow next to the Get Data and then select Web. Web connections are only established using basic authentication. Websites requiring authentication may not work properly with the web connector. In the From Web dialog, paste the URL. After connecting to the Wikipedia page, the Navigator dialog shows a list of available tables on the page. You can select any of the table names to preview its data. All these steps will be performed in the lab session. Hello everyone, in this lecture we're going to see how we can import data from web into Power BI desktop. So I have a website loaded onto my computer. The URL for this is worldometers.info/coronavirus. Let's just have a look at this website first. So it basically contains the active cases, the closed cases, the daily new cases, death tolls, and we have few tables in which we have the country names, we have the total cases, some new cases, the total death rate, and so on and so forth. So this is all of the detail country-wise for coronavirus pandemic. So what if we want to visualize such a data that is present on the web? So let's just see how we can connect to web on Power BI desktop. The very first step, as now probably you all are familiar with, is that we click on the Get Data option, and it gives us all of the options that there are in order to connect to. So I'm just going to type web over here, and you can see that here are the two options. I'm going to go with the first option. So when I hover on it, it tells me that it imports data from a web page. Let's just connect to it. Now it's asking me for a URL. So we have two checkboxes over here. Either you want to go with the basic option or do you want to go with the advanced option. So in the advanced option, you do have the URL part. You can add the part. You have URL preview. So you can change the HTTP protocols and stuff like that. But for now, let's just stay with the basic option. So I am going to copy the URL for this website and I am going to paste it in this field over here. And now let's just connect to it. So I've pressed OK and it's connecting. So it's establishing a connection. Now you can see that we have the navigator bar over here. Let's just see the options that it will display to us. It's taking a bit of time for me, and it also depends upon the amount of data that the web page has. So it takes about a little time in order to grab that. Now you can see over here that these are the table options. So we have some HTML tables, suggested tables. So let's just explore them one by one and see the preview over here on the right, that what sort of data do these tables they contain. So now you can see that they have country, they have the total cases, new cases, death tolls, we have new deaths, we have total recovered, active cases, and so on and so forth. So similarly in table 2, you can see over here that it's loading the preview and it contains somewhat similar information, and as does table number 3, I suppose. Okay. So these are all of the tables that are available on our web. Now it's totally up to us that which table do we want to load and which table do we feel like we need to visualize. So I'm just going to click on table number 1. I'm going to check this box and I'm going to load it. So this will load the entire table in my Power BI desktop, and this data is then ready for you in order to make your visualizations. And so you can see that this table contains these columns over here. So that's how you load or you import your data from a web to Power BI desktop. Thank you for watching. Now comes the juicy stuff. In this lecture, we are going to see how can we import real-time streaming data for visualization. You may have made the investment in a data and analytics tool that turns data into insights. You are able to visually explore and analyze your data in a single platform. While this is crucial to fostering a data-driven culture, if you aren't making decisions based on real-time data, you will fall short of your competition, for example, in customer services, in operational efficiency, and employees' motivation. Making decisions on real-time data allows you to make quicker, more proactive decisions than your competitors. Power BI features for real-time analysis. There are two ways of achieving real-time analysis in Power BI: automatic page refresh and streaming. Introduced in October 2019, automatic page refresh is a preview feature that allows for the full customization of Power BI desktop while also having data refreshed as frequently as 1 second. Introduced in 2016, streaming datasets can come from an Azure data stream, PubNub, or REST API, and they offer true real-time data. With Power BI real-time streaming, you can stream data and update dashboards in real time. Any visual or dashboard that can be created in Power BI can also be created to display and update real-time data visuals. First off, let's define the 3 categories of real-time data sets which are designed for display on real-time dashboards. These are not specific options you will find in Power BI, rather the choices you make when building the streaming data sets will result in the data set fitting into one of these categories. This data is pushed into the Power BI service. This is a special case of streaming dataset in which you enable historic data analysis in the streaming data source configuration dialog. Push dataset are stored in Power BI online and can accept data via the Power BI REST API or Azure Streaming Analytics. One of the most interesting things about push dataset is that, in spite of providing 5 million rows of history by default, they do not require a database. We can, in fact, push streaming directly from a source such as a device or executing code to Power BI Online's REST API. Streaming dataset data is also pushed into Power BI service with an important difference. Power BI only stores the data into a temporary cache which quickly expires. As the name implies, streaming datasets have limited or no history and just look at the most current values for each field. Because there is no history, there are only a few special purpose styles for showing streaming data in dashboards. The upside of using these is that they update on change, meaning that if your data changes every second, so will the tiles. These are situations where this is critical, so this is a very nice feature to have available in Power BI if you need it. PubNub is a third-party data service. It is designed with IoT in mind, but its powerful back-end data stores can provide data for chat platforms, log readers, and more. It is also free for up to 500 devices, each of which is essentially a data source. Hello everyone. In this lab session, we are going to see that how can we import streaming real-time data. But we're not going to do this in the Power BI desktop, but we're going to use Power BI services. So just type in powerbi.com and click enter. So it will ask you either you want to sign in or you want to try it for free or you want to buy it now. So if you don't have an account as of yet, just click on the try free option and sign up for a free account. Since I do have an account, so I'm going to sign into it. I saved my credentials, so it's just bringing me to the main workspace. So here I have options of workspaces. In my workspaces, I'm going to go into my workspace. So for the very first time, you're going to see this page, which is there to get data. So you can get the data of files from here. You can get the data from databases, services in my organization. But I am going to skip this for now. So just click on the skip option. Now let's just create a data set. To be precise, a streaming data set. Now we have different option, which is API, which is a REST API. We have Azure Stream, and then we have PubNub. We discussed these in the theoretical part. So I'm just going to go with PubNub for this one. And I'm going to click on next, and it's asking me for a data set name. So let's just say that I want this to be sensors data. So it's asking me for a subkey and it's asking me for a channel name. So let's just search for PubNub dataset sample. So I'm just going to click on this option. And you see we have Twitter sentiments, we have game state sync, we have the sensor data, Wikipedia changes, hacker news articles, market orders. So I'm just going to try this for the sensor data. Why don't you guys go ahead and try it for the Twitter stream? I think that's going to be interesting as well. So I'm just going to click on this option. Scroll it down. And you see that these are my streams. I have radiation, humidity, I have temperature, light level, and I need to accept the cookies. So here you see that we have a channel and we have a subscribe key. So let's just select this channel and paste it in the desired field. And let's just do the same with the subkey. So I'm just going to select this, copy this, and I'm going to paste it in the subkey. Just click on next. So now you can see that the name of the dataset is sensor data and the radiation level, ambient temperature, all of these are the fields, and you can see that these are their data types. So these are automatically assigned to them. Here's a little code for that. So I'm just going to create this. And now in the data sets, you can see that we have our sensor data. So this is how you import your data into the Power BI services. So this is actually the streaming data that we have imported into Power BI services. And in future, we're going to see that how can we use this data in order to fill our tiles. Thanks for watching. Hi everyone, and welcome to section 3 of the course. After data ingestion comes data cleaning and transformation. In this section, we are going to learn about this step. Data cleaning. Data cleaning is the process of ensuring that your data is correct and usable by identifying any errors in the data or missing data by correcting or deleting them. Data cleaning is required as the imported data is usually not necessary, helpful, and it comes to analyzing data because it may hinder the process of provide incorrect results. There are several methods for cleaning data depending on how it is stored along with the answers being sought. Data transformation. The data which is not useful to make a report and analysis, this type of data should be cleaned from our database. Let's see the common steps for data cleaning and transformation. Data cleaning and transformation tasks will be very dependent on the dataset that you're working with. In most cases, data cleaning involves number 1, removing unnecessary variables, deleting duplicate rows or observations, addressing outliers or invalid data, dealing with missing values, standardizing or categorizing values, and lastly, correcting typographical errors. We can achieve data cleaning and transformation in Power BI using Power Query Editor. Power Query is a data transformation and data preparation engine. Power Query comes with a graphical interface for getting data sources and a Power Query editor for applying transformations. Because the engine is available in many products and services, the destination where the data will be stored depends on where Power Query was used. Currently, there are 2 Power Query experiences available. Power Query Online. It is found in integrations such as Power BI Data Flows, Power Platform Data Flows, Azure Data Factory, Wrangling Data Flows, and many more that provide the experience through an online web page. The second is Power Query for Desktop. It is found in integrations such as Power Query for Excel and Power BI Desktop. It is important to discuss Power Query M language here, so let's get to it. In any data transformation scenario, there are some transformations that can't be done in the best way using the graphical editor. Some of these transformations might require special configurations and settings that the graphical interface doesn't currently support. The Power Query engine uses a scripting language behind the scenes for all Power Query transformations called the Power Query Formula language, also known as the M language. Hello everyone, in this lab we're going to see how we can use Power Query Editor in order to perform different data cleaning steps. So for that we need to load our data, so let's just get to Get Data. It's a CSV file. So I have this advanced economies file. I'm going to open it. Let's just see the actual data. So how about we previewing it? So, okay, I'm just going to select it and I am going to transform data instead of load. So very firstly, you see that we have the column names over here, and then we have some data. This is country, and these are some values of the advanced economies according to the year and the month. So what if I want to remove certain rows? For that, you have this remove column option, remove rows option in order to remove the rows. So it tells you or asks you that whether you want to remove them from top, you want to remove them bottom, you want to remove the alternate. So if I want to remove some rows from the bottom, I'll select that. And it's asking me the number of rows that I want to delete. So for instance, I want to delete 5 number of rows, and when I'll click OK, so it will remove some of the bottom rows. So let's just cancel this step by clicking the cross. Now you can see that we have 40 rows and 38 columns. And then again, let me apply this operation. So now instead of 40, we're left with 35 rows. So that's how the remove rows work. Now let's just try to remove a column. if I'll select this column and I click on remove column, this will be removed. And if I want to remove multiple columns, so I'll select this column. While pressing Ctrl, I'll select some other columns and click on this remove column option in order to remove. So since I don't want these to remain, or if I want to undo my steps, I'll just click this cross over here on the right, applied steps. The next thing that we're going to see is how can we remove duplicates. So for that, simply you'll go to remove rows and you'll click remove duplicates. If you have any duplicates, they will be removed. So since there are no duplicates over here, so that is why I have 40 rows intact. There's another option available if you have multiple columns. For instance, we have 38 columns over here and we don't have the time to scroll all of those. So we can select go to from the choose column. And over here you can see that there's a list of all of the columns. So let's just say I want to go to this column. I'll select this and click OK, and we'll move towards that. The next option that choose column provide is choose columns. So it asks you that what columns do you want to choose. For instance, I don't want to see column 1 and 2 and 3, and when I'll click OK, these columns will actually disappear from my view. They're actually present over here, but they're just hidden. So I can select them back in order to view them. So now let's just see how we can unpivot the column. For that, I'll go to transform. We have an unpivot column option over here. You see we can unpivot the columns. We can unpivot other columns or unpivot only the selected columns. So I don't want to unpivot this, rather other columns. So I'm going to select unpivot other columns. And now you can see that we have the country name, we have the attribute. So these are all of the column names, and then we have the values for those. Now let's just see how we can rename the column name. I'm going to right click and I am going to rename this as country, and I am going to rename the attribute as year and month, and the value remains the value. So if I want to split the year and the month, for that I'll just select this and I'll go to split column, and it's asking me, do you want to split it by a delimiter, by number of characters, positions, and so on and so forth. So I want it to be split by a delimiter. So I'll select that, and my delimiter is actually custom and the value for that is M, and now click OK. So here you see that we have the year and we have the month. So let's just again rename this. So it's year and rename again. So this is the month. So in order to replace a value, what you can do is click on this replace value option. And for instance, I want to replace 2014 with 2013. So just see all of the 2000 values over here that we have, and then I'll just click on OK. So it is changed to 2013. Then again, if you don't want this to be applied or you want to undo this option, just click on this problem solve. Now let's just see that how can we create certain columns. So I am going to close this editor and I'm going to get some data. So I'm just going to load this. Let's just transform this. So I'm going to go to home and I'm going to transform this data. And I want to add another column. So this is my query. And you see that we have the unit price and we have amount of sales. So let's just calculate the amount of sales per unit. So for that, I'm going to add a column, and it's going to be a custom column. So I'm going to select custom column option. I am going to name this as sales per unit, and the formula for that is going to be amount of sales divided by the units. Click OK. So you see we have another column. This column has been added and that's its name. So what if you want to change the data type for this column? Just click on this option on the left and you can change it to decimal number, fixed, whole number, whatever you want. So let's just change it to decimal number. So this is the data type now. So these are all of the basic operations that you can perform with Power Query Editor. There are a lot more, and we will see them as we move along the course. Combining two queries in Power Query or in Power BI is one of the most basic and also essential tasks that you would need to do in most of data preparation scenarios. There are two types of combining queries, merge and append. Database developers easily understand the difference, but the majority of Power BI users are not developers. In this lecture, I'll explain what is the purpose of append queries. Append means results of two or more queries, which are tables themselves, will be combined into one query. This way, rows will be appended after each other. For example, appending a query with 50 rows with another query with 100 rows will return a result set of 150 rows. Columns will be the same number of columns for each query. For example, column 1, column 2 up till column 10 in the first query after appending with the same columns in the second query will result into one query with a single set of columns from 1 till 10. When you have additional rows of data that you'd like to add to an existing query, you append the query. What about duplicates? Append queries will not remove duplicates. You have to use group by or remove duplicate rows to get rid of duplicates. What if columns in source queries are not exactly matched? Append requires columns to be exactly similar to work in the best condition. If columns in source queries are different, append still works, but will create one column in the output per each new column. If one of the sources doesn't have that column, the cell value of that column for those rows will be null. Hello everyone and welcome to the lab session, and this lab session is regarding the append queries. So we're going to see that how can we append two queries into one. So for that, first of all, I need to load the data. So I'm clicking on Get Data. And now I want a CSV file to be loaded into my Power BI desktop. Let's just connect to it. And I am going to browse it. Okay, so I have the files in the append queries folder. So you see the very first file, I am going to open it. So here are the columns for this particular file, and I want to transform my data. So I'm just going to click on Transform Data. Okay, so you see that we are here in an Power Query Editor. So here are all of my columns, right? So it's good for now. But I have only zip codes over here. I don't have the state name. The state name is Arizona. So let's just add a column which describes what state it is. For that, I will have to add a custom column. So I'll click on Add Column, and then now over here I'll add a custom column. So what is the name of my column? Let's just say that this is the state name, and the name of the state, actually the value for this is Arizona. Now it's giving me no syntax error, so let's just click on OK. So you see that a state name here has been added. So I only have one query at the moment, but what if I want another query, because I need to have some more queries in order to append them. So let's just go to Home, add a new source. So it's again a CSV, connect, California, open. So here is my CSV file. Let's just click OK, and it's going to open up in the query editor as the second query. And same as before, I want to add another custom column. So add column, custom column. This is going to be state name. And over here, the value for this is going to be, California, and click on OK. So here you see that a state name has been added. Let's just add another source. So go to Home, New Source, another CSV file, and this is Nevada. Okay, I am just going to repeat the step of adding a column. So add column and custom column. The name for this is going to be state name. And the value for this is Nevada. Okay, sorry. Okay. So now you see that we have another column over here. We do have that in California as well. And lastly, we have it in Arizona. So now I want to append all of these, because you see that the name of the columns is same in all of the queries. So let's just go to Home. Over here in Combine tab, you see that we have an append option. So it's giving me two options. Either I want to append the queries in this particular query, or I want to append the queries as new. So if I select append query, say it will add all of the queries that I select in Arizona. But I want to append it as a new query. So I'm just going to click on that option. So it's asking me whether you want to append 2 tables or you want to append 3 or more. If you want to append 2 tables, here is our primary table, and you can append another table from this list. But since there are 3 tables, so I'm going to click here 3 or more. So these are my available tables, and this is the table to append to. So I want to append California and I want to append Nevada. Just add these and click on OK. So now you see that we have another query, which is the 4th query, and its name is append1 by default. So let's just rename this query. I'm going to left click and click on rename and name this as all states. Now if I want only this query to be loaded and rest to be enabled, for that I will just enable the load for the others. Okay, and I am going to save and apply. So here you can see that we have the all states query and we have the state name over here. So now I'm going to select the table and I'm going to select state name to see the names of the states we have, and just let me increase the font size. So you see that we have Arizona, California, and Nevada all combined into one query. Thanks for watching, and in the next lab session, we are going to see that how can we merge queries instead of append. Let's start by explaining what merging queries in Power BI entails. Merge is another type of combining queries which are based on matching rows rather than columns. The output of merge will be a single query. There should be joining or matching criteria between 2 queries. For example, student ID column of both the queries to be matched with each other. Number of rows will be dependent on matching criteria between queries. Number of columns will be dependent on what columns selected in the result set. Merge will create a structured column as a result. When you have one or more columns that you'd like to add to another query, you merge the queries. Merge is similar to join. There are 6 types of joins supported in Power BI. Depends on the effect of the result set based on matching rows. Each of these types works differently. Hi everyone, in this lab session we're going to see how we can use merge queries in order to merge our tables. So previously we saw that how we can append them, which was based on the columns, and this is going to be based on rows. So I'm using the same file that I left off in the previous lab session. Let's just go to the query editor by using transform data. And here is our query editor, and you can see as previously these are our queries, and I want a new source to be added. So for that I'm going to click on new source option. It is a CSV file. Let's just connect to it. So here we have managers data. Let's just open it and first preview the data that we want to merge with the all states data. So here you see that we have zip codes and we have manager of store. So this is the name of the manager and this is according to the zip code. And as you remember that in the previous files, we do have zip code. So we have store zip codes. It's basically the same as the zip code, which is over here. So let's just load this. So this zip code column is basically going to be our joining column, as we need a joining column in merge queries, and we discussed the 6 types of joins that Power BI provides in the theoretical portion. So let's just go to all states and click on merge queries. So as append, merge query also gives us 2 options, whether we want to merge the query or we want to merge it as new. So we saw that how can we append it as new in the previous, so merge is same, but let's just go with merge query for now. So here it's giving me the table, which is the all states table, and it wants to ask me that which table do I want to merge to. So it's the managers table, and I want zip code to be the joining table. So I'm just going to select that column in both of the tables. And now it's asking me the kind of join I want to perform. So I'm going to say I want to perform the left outer join. So that's according to your requirements, your need. So according to the need that is fit over here, we have left outer join. So let's just click on OK. So you see that we have an other column which is added, and it contains these double rows. So let's double arrows actually. So let's just click here, and it's asking me you want to expand it on the basis of which column. So you want to select all of these or you want to select some particular ones. So let's just say that I want, since we already have the zip code, so I want the manager store name. So I'm going to select that and click OK. So this is the name of our manager, and this is joined according to the store zip code, right? So here you see that this is the store manager for this particular state and zip code. So that is how you merge your queries. Now I only want all states to be visible in my Power BI desktop for visualization purpose. So I'm going to enable the manager. So now let's just rename this column name, as this is not something very meaningful. So I am going to rename this by right-clicking it. So this is manager or manager name. Okay, so it's renamed. Now when I will close and apply, all of my changes will be applied. And so you can see that the changes are being applied, and we'll see shortly another column added over here in this list. Okay, so yeah, you can see that we have manager name added over here, as a field in our query, which is all states. Hi and welcome to section 4 of our course, and in this section we will discuss Power BI visuals. Power BI visuals. Power BI visuals allow the business users to perceive their data according to business point of view. Here you can see some visuals that are provided by Power BI. These visuals come pre-installed as a package when you download the Power BI software, and the icons for these visuals appear in the visualization pane. Power BI bar chart or horizontal bar chart is useful for the data comparison. For example, if you compare sales by color, region, or product group. Bar charts use horizontal bars to display data and are used to compare values across categories. The lengths of the bars are proportional to the values they represent. For a bar chart, the y-axis typically displays a category such as top grossing movies of 2019 in the above example, whilst the x-axis displays a discrete value. Now let's just discuss the column charts. In the case of showing change over a period of time, a column chart can also be displayed as a line chart. In a column chart, the y-axis typically displays a discrete value, whilst the x-axis displays the category. Bar chart versus column chart. Both bar and column charts display discrete categorical data and answer the question of how many or how much in each category. The categories are usually qualitative data such as movie titles, types of houseplants, or geographical locations. Bars in column charts are different to histograms as they do not show continuous development over any interval. Different types of data may suit either a bar chart or a column chart better. Now let's look into stacked bar and column charts. First up, we have a stacked bar chart. A stacked bar chart, also known as a stacked bar graph, is a graph that is used to break down and compare parts of a whole. Each bar in the chart represents a whole, and segments in the bar represent different parts of categories of that whole. Different colors are used to illustrate the different categories in the bar. This is an extension of the simple bar chart that we saw in the previous lecture. In a stacked bar chart, we can introduce two dimensions with a measure as opposed to a single dimension in a simple bar chart. The second dimension can be used to subcategorize the first dimension along with the measure values. For example, in the figure above, we have two dimensions, sales territory and buying package, and a measure total including tax. The second dimension depicts the categorization among how the sales for a particular sales territory is divided. The next visual is a stacked column chart. A stacked column chart is a basic chart type to allow part-to-whole comparisons over time or across categories. In a stacked column chart, data series are stacked on top of one another in vertical columns. Stacked column charts can show change over time because it's easy to compare total column lengths. However, except for the first series of data next to the x-axis and the total bar length, it's difficult to compare the relative size of the components that make up each bar. As categories or data series are added, stacked column charts quickly become complicated. Let's say you have been asked to create a graph to illustrate the demographics of the marching band at your local high school. Specifically, you should show how many students play each of the following four instruments: drums, trombone, trumpet, and tuba. You need to show how many of the musicians are male and how many are female for each instrument. You could create two bar charts, one for the boys and one for the girls. Or you could combine the information into a stacked bar chart. Let's take a look at what that might look like. So in this chart, the two categories for each bar are boys and girls. The key tells you the red represents the girls in the band and the blue represents the boys. Hello everyone, in this lab we're going to see how we can create bar and column charts. So for that we need to import our data first. I've clicked on Get Data option. Now I'll select the Excel option and I will connect to this. And from here I'll select Financial Sample and click OK. Shortly you'll see some fields, but first we have a navigator bar. So I'm going to select Financials sheet number 1 and I'm going to click on Load. So it's loading our data. It will take a few seconds to establish a connection and to load the data. So now you can see all of the fields that we have for this particular query, also known as a table. So here you see in the visualization pane, we have different visualization options. So we have a stacked bar chart and we have a stacked column chart and so on and so forth. So all of these visuals, we're going to explore them. So I'm going to select a stacked column chart and I'm going to select sales and country. So here you can see that we have sales by country. Now I know you must be thinking that we selected a stacked column chart, but we have got a simple plain column chart. That's because when we'll add more of the attributes over here, that option will be automatically added and it will be converted into a stacked column chart. For instance, let's say that we want to add discounts to it. So here you see that now we have sales and then we have discounts. So that column chart is converted into a stacked column chart. Similarly, we can work our way around with bar charts. So if I want to convert this column chart into a bar chart, I'll select this option. And now you can see that the vertical columns, they're converted into horizontal rows. In this lecture, we are going to see what is a line chart and in what situations we can use it. A line chart is a graphical representation of an asset's historical price action that connects a series of data points with a continuous line. This is the most basic type of chart used in finance and typically only depicts a security's closing prices over time. Line charts can be used on any time frame, but most often using day-to-day price changes. Let's see the uses of line charts. Line charts are excellent for mapping continuous data sets over a period of time. Understanding changes happening over a period of time is relatively easier for the human mind. Business owners want to see profits increase over time. Content publishers want to see traffic increases over time. And public bodies want to see tax, health, or infrastructure data over time. It gives us the best context to understand what's happening and how to plan for the future. Line charts help in observing trends and identifying key performance issues, either good or bad. Line charts let you find the exact time something out of the ordinary happened, which helps in pinpointing where to drive for answers. Multi-series line charts are used to compare how different groups, irrespective of how they're segmented, geography, internal teams, age groups, financial quarters, etc., are performing compared to each other. This helps in identifying key performance areas and to quarantine conditions that are affecting negatively. Moving on in this lab, we're going to see how we can use a line chart and how can we create one. So we have the same data which we loaded in the previous lab. We're going to use that data. I'm going to select a line chart from here. and I'm going to select the sales data, and I want to display it according to the date. Now you see that we have 2 years over here. We have 2013 and we have 2014. What if I want the data for only 1 year? So for that, we have the option of filters that you can see over here. So if I drop this down, you see that we have advanced filtering and then we have basic filtering. So in basic filtering, I have two options, 2013 and 14. What if I select 2014? So now you see I only have a single dot over here because it's representing the sales data for one particular year. But we need the data for months. So you see that we have some arrows over here. So they are used for drilling down. So let's just click this because we want to turn on the drill down option, and then click on this double arrows for going on to the next hierarchical level. So here you see that now we have the sales by quarter. So we have quarter 1, 2, 3, 4. When I click on it again, now we have the sales by month. So that is how drilling down works. Now let's see that I want to add another trend to it, which is of cost of goods sold. Now when I'll click on it, you see that we have another line. So that is the trend monthly for cost of goods sold, and the line above is for sales. So that is how you use and how you create a line chart. Hi everyone, we are going to discuss how and when can we use pie charts to visualize our data in this lecture video. A pie chart shows how a total amount is divided between levels of a categorical variable as a circle divided into radial slices. Each categorical value corresponds with a single slice of the circle, and the size of each slice, both in area and arc length, indicates what proportion of the whole each category level takes. The pie chart above depicts the distribution of votes for a fictional election for a small city. We can see that race, represented by the first blue slice, has just less than half of the votes. Chew yellow is in second, with about a third of the votes, while William Purple is last, with about a fifth of the votes. The annotations in the upper right give us a more precise judgment of the proportions, but the pie chart tells the overarching story of where the votes fell. Pie charts have a fairly narrow use case that is encapsulated particularly well by its definition. In order to use a pie chart, you must have some kind of whole amount that is divided into a number of distinct parts. Your primary objective in a pie chart should be to compare each group's contribution to the whole as opposed to comparing groups to each other. If the above points are not satisfied, the pie chart is not appropriate and a different plot type should be used instead. It is best practice to never have any more than 7 categories, as it becomes harder for the eye to distinguish relatively of size between each section. Okay, now using the same data, we're going to see how we can create a pie chart. So in the theoretical portion, we already mentioned that we need to use a pie chart if we have categories not more than 7. Otherwise, you need to use a bar chart or a column chart for better visual impact. I'm going to select sales data, and now I'm going to select the product category. So you can see that we have around 6 products. So that's why pie chart is an option. Select this chart, convert it into a pie chart by clicking this visual. So now you see we have sales by product, and these are all of our product categories and their respective sales. Let's just go to format and to legends. And if I increase the size from here, you can see that our legend size has been increased and it is more visible now. Similar, we have an option in data colors. So all of this is in the format pan. So here you can change the colors. For Paso, you can go to pink, or make it light purple. So you can see that we can change the colors in this particular manner. Let's just see the detail label. So here we have data value and percent of total, and this is basically our detail label. So you can change it to category. So now you see that we have products as the detail label. You can create 2% of total. Let me just increase its size so it's more visible. You can change it to category in percent of total and category or data value. So you have all of these options to play around with. So what if I want to change more information when I hover over it? That is, in addition to product and sales, I want, for instance, the profit to be visible. So for that, I need to add these options to the tooltip. Going back again to the fields, and over here in tooltip, you'll drag and drop profit. Now you see that when I hover over it, I do get the information regarding the profit as well. Also, we have another option is of adding another additional category. So for instance, I want years to be added as a category. So when I've added year to the details pan, you see that we have additional lines over here. So basically this is for 2013 and this is for 2014, but our pie chart is clustered with a lot of information and it's not easy on the eye. So I am just going to remove this to make it a little more clean and simple. But adding the year category to details was just an option to show you that how you can play around with your pie chart. So that's it for today. Thank you for watching the video. Hello everyone. We are going to see what are map charts in this lecture. So let's get to it. A map chart is used to show items on a background that is often, but not always, geographical. Map charts in Power BI can contain different types of information in one or more different layers. Maps can contain interactive shapes or display markers of different types on an image or map background. What is sent to Bing Maps? The Power BI service in Power BI Desktop sends Bing the geo data it needs to create the map visualization. This may include the data in the location, latitude and longitude buckets of the visuals field well. In the example on the right, the field vendor is being used for geocoding, so the values in the vendor column are sent to Bing data. Data from the size and color saturation buckets is not sent to Bing. In the second example on the left, the field territory is being used for geocoding, so the values in the territory column are sent to Bing. Data from the legend and color saturation buckets is not sent to the Bing. I'm going to explain some useful tips while using the map charts to use them more effectively. In Power BI Desktop, you can ensure fields are correctly geocoded by setting the data category on the data fields. Sometimes even setting the data categories for mapping isn't enough. For Bing to correctly guess your intent, some designations are ambiguous because the location exists in multiple countries or regions. Add latitude and longitude values to your dataset. This removes any ambiguity and returns results more quickly. While it is encouraged you to use geo-hierarchies in your maps, if you must use a single location column with full geographical information, you can set the data categorization to place. Hello everyone. In this lab, we're going to see how can we use maps in our Power BI desktop. So I'm using the same data that we used in the previous labs. From here, I'm going to select the map visualization. Let me just expand it. So I'm going to select country. So now you can see that here are some dots which represent the countries which are in our data. So I have a dot at United States, one is in Canada, one is in Mexico, we have one France and Germany. So I want to represent the sales on the map per country. So now you can see that we have certain bubbles. So over here you can see that in the size category we have sales. So the size of the bubble or the dot, it depends upon the amount of sales. So here the sales in country United States of America is this much. And in Mexico we have least amount of sales. Also, if you want to add something to the tooltip, for that we'll just drag and drop that thing. So for instance, I want to see discounts in the tooltip. So now along with the sales, the discounts are also available. What if I want to deselect sales and I want the manufacturing amount or price to be visible? So I'll select that. So you can see that the size for all of the bubbles, it has changed. Now if I want product to be displayed in the legend, I'll just drag and drop that into the legend fields. So you can see that I have these certain pie charts over here, and it actually represents the legends for the products. So that is also one way you can use the legends. Cards and multi-row cards are a vital part of data visualization. So we are going to see what's their purpose and how to use them. Let's discuss a single card first. Sometimes a single number is the most important thing you want to track in your Power BI dashboard or report, such as total sales, market share year over year, or total opportunities. This type of visualization is called a card. Multi-row cards. Power BI multi-row card is useful to display the data in a group format or section-wise. We will further see both these visualizations in the lab sessions. Okay, so now let's just see that how we can use card and multi-row cards. So let's just choose the visual from the visualization pan. And the value we want to display as a whole is sales. So here you can see that this card gives a lot of information. That is the total sales for all of the products. So we have this as a card over here and it displays that information for us. And also let's just display or make another card. And what do we want to display? For instance, we want the gross sales to be displayed. So this is our gross sales and this is our sales. Now, if we want to display the sales with respect to products or with respect to countries, then how we can do that? We can do that by using a multi-row card. Let's just select this and now scrolling up, I'm going to select the country first. All of the countries are here. Now I want to display the sales. So you can see that these are the sales country-wise. How about I just increase the size? So for that, just go in card title and increase the text size. So here the card title has been increased. And I want the data to be increased as well. So the category, let's just increase the size for that. And now lastly, let's just increase the size for the data label. Yeah, so I think now it is more visible. So here you can see that our multi-row card contains countries and their sales, but What if we want to say it country-wise, product-wise, and sales-wise? So I'm just going to add product into the fields. So yes, now we have the sales with respect to the country and with respect to the products. And what if I want to include the discount bands into it? So here are the discount bands. I'm just removing this because I want to show you one other thing, is that for now our sales are present here in terms of sum. But what if I want to calculate its count, its variance or median? So you can select any of this option. So what if it's maximum? So you can see that the values are changed. So the maximum of sales in France is this much, for Canada it's this, and so on and so forth. Or what if I want to show it as a percent of the grand total? And now here you can see that we have the percentages. So let's just say I want to keep the sum. So now it's just percentages of the sum of the sales. So that's how you can use a multi-row card, and it gives off a lot of information when using in your visualizations. Hi everyone, this lecture video is about key performance indicators, also known as KPIs. A key performance indicator is a measurable value that demonstrates how effectively a company is achieving key business objectives. Organizations use KPIs at multiple levels to evaluate their success at reaching targets. High-level KPIs may focus on the overall performance of the business, while low-level KPIs may focus on processes in departments such as sales, marketing, HR, support, and others. KPI as a decision-making tool. Effective decision makers understand that they need information on the key dimensions of performance and that this can be achieved by distilling them into the vital KPIs. Similar to the way a doctor would go about trying to understand someone's health, instead of measuring random things, a doctor would focus on key health measures first. For example, taking your blood pressure and measuring your cholesterol levels, heart rate and body mass index as key indicators of your health. In our organizations, the most effective KPIs are closely tied to strategic objectives and help to answer the most critical business questions. When to use a KPI? KPIs are a great choice to measure progress. Answer the question, what am I ahead or behind on? To measure distance to a goal, answer the question, how far ahead or behind am I? We will see how to effectively use KPIs in our lab session. Okay, now we're going to cover a very interesting topic, which is KPIs. So you know the drill that we're going to use the same data. And let me just scroll this date field down. So we have date hierarchy created. We have the year, quarter, month, and day. So this is the visual for KPI. And I'm going to select the sales for this KPI. And for date, I want to see it monthly. So here you can see that we have 17.37 million of sales, and this is the monthly graph for that. But in KPIs we do need to have a target goal so that we can see that did we achieve our goal or not. So let's just take cost of goods sales as our target because we need to meet our cost, and the rest will be the profit, of course. So you see that the color now has changed to green, so that means that we have reached our goal and we are making profit. Great. So let's just make another KPI visual. I'm going to use the units of goods sold for this one, and that too monthly. So we have this figure of units sold monthly, and this is the curve or the graph for that. But we don't have any target as yet for this. So let's just see that how we can create a number and use it as a target goal. So for that, I'll click on this new measure option. So this is part of DAX that we'll see in the lectures to come forward. Let's rename this to target, units sold, and keep this value around 18K. So, supposedly that was our goal. Now, when I'll click enter, so you see that we have a measure added over here. Let's just drag and drop it into the target goals. Okay, so now it is evident that the color for this is red, and that means that we are this much behind our goal. So we are 13.72% behind our goal. So that is how you can use KPIs in order to measure your progress. Today's discussion is regarding word cloud and its use. Google says a word cloud is an image composed of words used in particular text or subject, in which the size of each word indicates its frequency or importance. So the more often a specific word appears in your text, the bigger and the bolder it appears in the word cloud. Where word clouds excel for businesses. Finding customer pain points and the opportunities to connect. Do you collect feedback from your customers? You should. Analyzing your customers' feedback can allow you to see what your customers like most about your business and what they like least. Pain points such as wait time, price, or convenience are very easy to identify with text clouds. Understanding how your employees feel about your company, and also identifying new SEO terms to target. In addition to normal keywords, research techniques using a word cloud may make you aware of potential keywords to target that your site content already uses. Okay, fellows, so now we're going to see that how can we use a custom visualization in Power BI Desktop. So the visualization that we're going to use is the word cloud. I'll click on these three dots that you see here in order to get more visuals, and I'm going to get more visuals. So window will appear in front of you, and you can see that the second option is a word cloud. So let's just add this. So the visual has been successfully imported, and here is the visual, and we're going to use this. But for this to be used, we need some other data, some textual data. So I'm going to click on Get Data. Now I'm going to click on Text and CSV and Connect. So here is the books data that we have. Okay, so the delimiter is comma over here. Let's just change it to equal sign so that everything is in one column and load it. So we only have one column in this query, and I'm going to click on this visualization, bring it in the center, expand it, and click on this field. So yeah, so these are the words that are being used in the text that we have. So the size of the text tells us that how frequently it has been used. And when you hover on it, you can see the count as well. So that is how you use a word cloud. Power BI and analysis services rely on a semantic model based on the tabular object model. In this section, we are going to study this phenomena in detail. Data modeling is one of the features used to connect multiple data sources in BI tool using a relationship. With the modeling feature, you can build custom calculations on the existing tables, and these columns can be directly presented into Power BI visualizations. This allows businesses to define new metrics and to perform custom calculations for those metrics. Put simply, Power BI relationships propagate filters applied on the columns of model tables to other model tables. Filters will propagate so long as there's a relationship path to follow, which can involve propagation to multiple tables. Relationship paths are deterministic, meaning that filters are always propagated in the same way and without random variation. Relationships can, however, be disabled or have filter context modified by model calculations that use particular DAX functions. In this image, you can see a common data model which shows a relationship between two tables. Both tables are joined using a column name ID. Similarly, in Power BI, you set the relationship between two objects. To set the relationship, you have to drag a line between the common columns. You can also view the relationship in a model in the Power BI. Each model relationship must be defined with a cardinality type. There are 4 cardinality type options, representing the data characteristics of the from and to related columns. The one side means the column contains unique values, and the two side means the column can contain duplicate values. When you create a relationship in Power BI Desktop, the designer will automatically detect and set the cardinality type. The designer queries the model to know which columns can contain unique values. A one-to-one relationship means both columns contain unique values. This cardinality type isn't common, and it likely represents a suboptimal model design because of the storage of redundant data. Many-to-one. A many-to-one relationship is the most common default type of relationship. It means the column in a given table can have more than one instance of a value, and the other related table, often known as the lookup table, has only one instance of a value. One-to-many. In a one-to-many relationship, the column in one table has only one instance of a particular value, and the other related table can have more than one instance of a value. On both sides of the relationship, the columns can have duplicates. This feature was introduced in 2018, and unfortunately, its name is somewhat confusing. Indeed, in common data modeling language, many-to-many refers to a different kind of implementation created by using pairs of one-to-many and many-to-one relationships. It is important to understand that in this scenario, many-to-many does not refer to the many-to-many relationship, but instead to the many-to-many cardinality of the relationship. Hi everyone, and welcome back to another lab session. And in this lab session, we're going to see what is modeling and relationships when we talk in terms of Power BI. So you know the drill, we need to click on Get Data first. I'm going to select Excel, click on Connect. Going to go to Downloads. I have some fast food chain data available here. So I need all of these 4 queries uploaded into my Power BI. So starting with the first one, which is branch data, I'm going to click Open. So the first sheet and the only sheet is what I want to upload. So here is my data. I am going to transform my data first because I want to make some changes to it. So we are on to the Power Query Editor. And here is our data. So I want all of the other sources to be uploaded as well. So I'll click on New Source. And the other source is also of type Excel. I'm going to connect. Bring in daily sales target. Click on Open. This is my data that I require. I'm just going to select this and click on OK. Similarly, we're going to repeat this operation for the next 2 queries or tables as well. So we need sales data, and lastly I'm just going to bring in the sales target. Again, new source. So just select sales target and click on OK. And now we have all of our 4 queries with us. So let's just examine these before we move on towards the modeling and relationship. So in the first query, we have 3 columns, but you can see that the names for the columns is not appropriate because this is the branch category and these are the managers and this is the country. So in order to convert your first row to your column names, you have an option over here which is used first row as header. So simply click onto it. And now you can see that all of this has been managed for us. But what if we want to change the name of our column? Since you see that this column is not the manager name, rather it's the country. So just double click onto it and change this to country. Rest seems fine. The daily target is the day and the target. So it's according to the day you need to achieve these many sales. So that's the information that is kept in this table. Next we have the sales. So these are all of the daily sales. They contain the serial number. We have date, branch, pizza type. We have the quantity of the pizzas. Those are sold, time range, and the price. And lastly we have the sales target. That is per pizza type. How many sales target are to be achieved? So I hope that all of this is clear to you. Now let's just close and apply. So it's applying the appropriate changes to all of the queries and loading the queries into the Power BI desktop. So you can see that we have all of our queries over here. Now what was left unexplored earlier is that we have these 3 options. The very first is the reporting option, the one in which we work, and we have been working for the past all of the labs. Next, we have the data in which we can view the data by clicking the queries. Okay. And lastly, we have the model option. So this model option is where we're going to see the modeling. Okay. So you can see that all of our 4 queries are over here. And there is a relationship, an automatic relationship detection between branch data and the sales data. So when you see that the names of the columns are same, such as in this case, branch and branch have the same column names, so automatically Power BI Desktop creates a relationship amongst them. And this arrow is the representation of that relationship. So let's just double click onto it. So now you're seeing that this branch and this branch data is same and relationship has been established between them. And the cardinality for this is many to one. So you can change the cardinality by scrolling down and selecting any of the cardinality. So this cardinality has been automatically detected and mostly it is accurate. So I'm just not going to do anything over here. Click on OK. But now you can see in sales target we have pizza and in sales we have pizza type. Both of these columns, they contain the same value and we can create a relationship amongst these two on the basis of that. But an automatic relationship has not been created because the name of both of the columns is different. So in order to create a relationship, I'm going to select this column and I'm going to drag and drop to the column I want its relationship to be created to. And now you can see that an arrow exists between the two. When I hover over it, both of the fields are highlighted. Now let's just double click onto it. And now you can see that pizza and pizza type, both of them, they have a relationship and it's a many to one relationship amongst them. Click OK. Now back to our reporting section. Now all of the relationships have been established and now we can use all of these queries in our reporting tab. And these joins have been established, so all of the data can be maintained and displayed and visualized accordingly. Hi everyone, in this lecture we're going to discuss what is normalization and denormalization in Power BI. First up for discussion is data normalization. When any database developer worth his or her salt designs a transactional database, they apply the rules of data normalization. These rules find values that are repeated within the data and store those values in separate tables. Smaller and more efficient ID values are placed in the original table and the new table, so the records in these tables maintain an association called a relationship. This allows the database to take up less space and makes it easier to insert new values and update existing values. For example, each delivery has customer information associated with it, as shown in the table before normalization. However, we don't want to repeat the customer name, city, and other information in each and every record in our delivery table. Instead, we create a customer table and use a customer number to link customer table records to delivery table records. Now let's see what is data denormalization. Data normalization works great when we are trying to create an efficient transactional processing system and utilize the smallest amount of disk space. However, if we want to create a report on the deliveries completed for each customer, we must put these separate tables back together. In most cases, we won't have all of the individual customer numbers memorized. We need to see the customer names. One way to do this in our Power BI data model is to load both the delivery tables and the customer table. These would then exist as two separate tables in the data model. However, if our source database is configured properly, Power BI offers an alternative, a way of handling this situation using the value column. Data warehouses usually use a denormalized data because the data in a data warehouse does not need to be organized for quick transactions. More normalized your data is, the more complex the queries needed to read the data because a single query combines data from many tables. A denormalized data structure uses fewer tables because it groups data and doesn't exclude data redundancies. It offers better performance when reading data for analytical purposes. Hi guys, today we are going to talk about Online Transaction Processing Systems (OLTP) and Online Analytical Processing Systems (OLAP). Online Transaction Processing. OLTP is characterized by a large number of short online transactions, such as insert, update, and delete. The main emphasis for OLTP systems is put on very fast query processing, maintaining data integrity in multi-access environments, and an effectiveness measured by number of transactions per second. In OLTP database, there is detailed and current data. And schema used to store transactional databases is the entity model. An example of OLTP system is ATM Center. Assume that a couple has a joint account with a bank. One day, both simultaneously reach different ATM centers at precisely the same time and want to withdraw total amount present in their bank account. However, the person that completes authentication process first will be able to get money. In this case, OLTP system makes sure that withdrawn amount will be never more than the amount present in the bank. The key to note here is that OLTP systems are optimized for transactional superiority instead data analysis. Online Analytical Processing. Online analytical processing, a category of software tools which provide analysis of data for business decisions. OLAP systems allow users to analyze database information from multiple database systems at one time. The primary objective is data analysis and not data processing. Any data warehouse system is an OLAP system. Uses of OLAP are as following. A company might compare their mobile phone sales in September with sales in October, then compare those results with another location which may be stored in a separate database. Amazon analyzes purchases by its customers to come up with a personalized homepage with products which likely interest their customers. Let's just compare the both. Benefits of OLTP method include administration of daily transactions of an organization. OLTP widens the customer base of an organization by simplifying individual processes. Benefits of OLAP include creation of a single platform for all type of business analytical needs, which includes planning, budgeting, forecasting, and analysis. The main benefit of OLAP is the consistency of information and calculations. Easily apply security restrictions on users and objects to comply with regulations and protect sensitive data. OLTP is an online transactional system. It manages database modification. OLAP is an online analysis and data retrieving process. OLTP is characterized by large numbers of short online transactions, whereas OLAP is characterized by a large volume of data. Also, OLTP is an online database modifying system, while OLAP is an online database query management system. Snowflake and star schema hold grave importance when data modeling and data warehousing is concerned. Hence, I'm going to explain both of these in this lecture. What is multidimensional schema? Multidimensional schema is especially designed to model data warehouse systems. The schemas are designed to address the unique needs of very large databases designed for analytical purposes. Following are two chief types of multidimensional schemas, each having its unique advantages. First, star schema. Second, snowflake schema. Beginning with snowflake schema. Snowflake schema is also the type of multidimensional model which is used for data warehouse. In snowflake schema, the fact tables, dimension tables, as well as the subdimension tables are contained. This schema forms a snowflake with fact tables, dimension tables, as well as subdimension tables. The main benefit of snowflake schema is that it uses smaller disk space. Easier to implement a dimension is added to the schema. Due to multiple tables, query performance is reduced. The primary challenge that you will face while using the snowflake schema is that you need to perform more maintenance efforts because of the more lookup tables. Star schema. In the star schema, the center of the star can have one fact table and a number of associated dimension tables. It is known as star schema as its structure resembles a star. The star schema is the simplest type of data warehouse schema. It is also known as star join schema and is optimized for querying large data sets. Characteristics of star schema. Every dimension in a star schema is represented with the only one dimension table. The dimension table should contain the set of attributes. The dimension table is joined to the fact table using a foreign key. The dimension table are not joined to each other. Fact table would contain key and measure. The star schema is easy to understand and provides optimal disk usage. The dimension tables are not normalized. The schema is widely supported by BI tools. Let's chalk down the key differences amongst the both. The key differences amongst both the schemas are: number 1, in star schema, hierarchies for dimensions are stored in dimensional table, and in snowflake schema, hierarchies are divided into separate tables. Star schema contains a fact table surrounded by dimension tables, and in snowflake, one fact table surrounded by dimension table, which are in turn surrounded by dimension table. In star schema, queue processing is faster. On the other hand, queue processing might be slow because of complex joins. In a star schema, only single join creates the relationship between the fact table and any dimension tables, whereas in a snowflake schema, it requires many joins to fetch the data.
Hi everyone and welcome to section 6 of our course. This section is the most important part of the entire course, so without further ado, let's get to it. What is data analysis expression, also referred to as DAX? DAX stands for Data Analysis Expressions. It is language developed by Microsoft to interact with data in a variety of their platform like Power BI, Power Pivot, and SAS tabular models. Using DAX will truly unleash the capabilities of Power BI. Let's see data types supported in Power BI Desktop and data analysis expressions. Here is the list of all data types that are available in Power BI DAX. We will be working with them alternatively in the lab sessions. The data analysis expression language uses operators to create expressions that compare values, perform arithmetic calculations, or work with strings. There are 4 different types of calculation operators: arithmetic, comparison, text concatenation, and logical. To perform basic mathematical operations such as addition, subtraction, or multiplication, combine numbers, and produce numeric results, use the following arithmetic operators. You can compare 2 values with the following operators. When 2 values are compared by using these operators, the result is a logical value that is either true or false. Use the ampersand to join or concatenate 2 or more text strings to produce a single piece of text. Use logical and or operators to combine expressions to produce a single result.
Hello everyone, in this lab session we're going to see that how can we create a custom column and how can we create custom measures. So let's start with custom column. So I have some data loaded over here just to save time, and you can see that in dim customer table or query we have certain data. So also we have the first name and we have the last name separated. So let's just combine them in one column. So for that I am going to go to these 3 dots and I am going to create a new column. Let's just name this column as the full name. And here we have the first name. We are going to join it with the ampersand sign. And I want a space and another ampersand sign and the last name. And click on the check mark. So now you see that we do have a column over here. Let's just go to the data in order to explore it. Yes, so here you can see that we have the full customer name, we have its first name and the last name. So we have Larry Gill. Let's check the first and last name for this customer. So here is the name, first name Larry and the last name Gill. So that is how you create a custom column. But now let's just see that how can we create a custom measure. So for that, firstly, I am going to make a new table, and for that I need to go on Home tab and I'll click on this Enter Data option. Now it is asking me the name of the table, and let's just say this is some new table and we have to give the value to this column. So I'm just giving it 1 and pressing load. So after some time, our table will be created or query will be created right here. Yeah, so you can see that we have a new table over here. And when I scroll it down, you see the column 1 that we entered the value for. So just click on these three dots, click on new measure. I am going to name this new measure as total sales, and here I am going to use the function sum in order to sum the fact internet sales extended amount, and I'm going to click on this tick. So it's asking me to rename the total measure as this name has already been used, new total sales. So it's working on it, and yes, here is our measure. Now we need to check this, whether we calculated it right or not. So for that, first of all, we need to have a category. So I'm going to go to DIM product subcategory and check the English product. So these are the subcategories. Or, let's just don't go with the subcategory rather than the category. So here are our categories. I'm going to increase the size in just a bit, but first let me just click on this measure, and now let's just increase the size. I'm going to the Formats tab, I am going to General, and here, I'm going to go to Values in fact, and here I'm going to change the font size to 28 and expand it so that it is visible. So these are our total sales, these are the sales for bikes, and these are for accessories, and these are for clothing. So that's how you create a new column, and how you create a new measure, and how you create a new table. Now we're going to see some basic analysis functions of Power BI DAX. We've already seen how we can use the sum function, and now I'm going to use the average function. Same in the new table. In the new table, I'm going to click on these three dots, and I am going to create a new measure. The first function that we're going to use is average. So I'm going to calculate the average sales per product. So let's just say average sales. I'll make it new average sales. I am using the average function, and the column that I'm going to use is fact internet sales extended amount. Bracket close. Click on the check mark. So new measure is created over here, which is new average sales, and this is also per product. I'm just going to select this table and click on this new measure. So now you can see that we have this much average sales for the bikes category, this much for the accessories, and this much for the clothing. Okay. Yeah. So if you want to change the decimal places, you can do it automatically by defining them over here. So it's gone to 0 decimal place. I'm just going to select 2, actually type 2 and press enter. So it's working on it, and now we'll have it up to 2 decimal places. So that's how you can work around with it. Another measure that I would like to create over here is the maximum sales for the product. So the maximum sales value, max sales, and the function is max, and the column that we're going to use is fact internet sales extended amount. It's going to work its magic, and we have a new measure. So let's just select this visual and select max sales, and here we go.
So these are the maximum sale that happened per the product category. So in a similar fashion, you can also use the minimum function. So let's just do that. Min sales. Also, this is going to be per category, the product category. The name is min, and here the name of the column is fact internet sales extended amount. I'm going to click on the check mark, and yes, we have it here. So let's just see the value. I'll actually have to minimize, not actually minimize, but change the size because my page is a little short for this. So I am going to go to values and I'm going to change the font size to maybe to around 22. Let's just minimize this. Okay, so these are the minimum sales per category. So the minimum amongst them is 2.29. So that is how you can use functions in your reports, and you can create measures using that and extract some more meaningful information out of that. Thank you for watching. Okay, now so we're on to the time analysis functions, and in order to apply the time analysis we need to have a date table. So in some data where we don't have a date table, we can create a date table. But before we begin on with the analysis, I need you all guys to go to File, Option in Settings, Option, go to Data Load, and just check this Time Intelligence option and click on OK. So now let's just learn how we can create a new table. So go to Modeling, create a new table. So here I am going to name my new table as new cal date, and I'm going to use the calendar auto function in order to create this table. I'm going to click on the tick mark. So it's going to create a table for me. Here is my table. Let's just go to data and then the new cal date, and here we have the date. So it has picked up the date from 1916, and let's just see the end date is in the year 2018. Now what cal date auto, actually the calendar date auto function does is that it goes to your data, it actually saw the minimum date there is and the maximum date there exists, and creates a table containing all of the dates in between. So this can be a bit problematic because it takes a lot of memory space. So we have an alternate option for that, which is calendar. So let's just go to that. But before that, let's just see that what dates do we actually require. So in fact internet sales, let's just go to order date. So we do have a date hierarchy over here. I'm just going to select this. And here, let's just drop it down, go to basic filtering in order to see all of the years. So we have year 2010 till 2014, which is of importance to us. So let me just delete this and go to modeling and create a new table.
I am going to name this table as new caldate using cal. So we are using the calendar function. So we need to mention a start date and an end date. So I'm going to say that I want a minimum order date, but wait, I want this to be my year, and 1, because I want to start it from January the 1st of that particular year. So we need to convert it into the date. Now just put a comma and write max of the order date. Then again I need this as a year, so let me convert this, and we need a date definitely, and that date will be 12th month and 31st of December. Right, just click the tick. So it's working on it now. We have another table over here. Let's just go to data and see the data for this. So now you can see that 2010 is the starting year, and we're going up till 2014. And this consumes a lot less space as compared to starting from the year 2000, not actually 2000, but 1916, I guess. Now let's just add some more things to our table. I'm going to go to data again. Here. Actually back to home. And here we require a new column. I am going to name this column as the year, and here we are going to use the year function, and the date is basically going to be the new cal date. This is our date column. Let's just click on the tick mark and see what happens. So we have a year column over here, and this is the year, and this is the year actually extracted. So that is how you make a calendar date table. So let me just show you another function. So I'm going to create another column. We're going to do this for the quarter now. So let's just name it quarter, and quarter is our function, and the date is from new cal date using cal. So it's actually the date. So new cal date, yeah, this. Now we're going to get the quarters out of it. So we have it. Let's just make another. How about the month now? Going to use month and new cal date. And similarly, we can have the day as well. So that is how we can create a calendar table. And we can use this in the time analysis. Yeah, so lastly, we need the days. So day, and the column is this. Okay, so let's just see it. So now you can see that we have the quarters and we have the months and we have the days. So here we have this small and very precise calendar day table, and you can use many other functions in this as well, but these are the main functions that you can use in order to create this table. So thank you for watching, and in the next video we're going to use some other functions of time analysis using this cal date table. Okay, now so we're going to create a new measure which is based on the function same period last year, and it returns a table that contains a column of dates shifted 1 year back in time from the dates in the specified dates column in the current context. So I'm going to select the matrix over here and new total sales, and from my date table I'm going to select the date. So let me just increase the font for this. Going to go to column headers, increase it to 20, and same for the row headers. Let's just make it 20, and for the values, how about we go with 18? Okay, let me just expand this so that you guys can view it. And if I drill down, so here is the sales according to quarter, month and day. Now we're going to create a new measure in our new table, new measure, and we're going to name it as the sales last year. So sales last year. And we're going to use another new function over here, which is calculate, and it evaluates an expression in a context modified by the filter. The expression over here is new total sales, and the filter is basically same period last year, and it's in the date table, date dot date, as we need the date. Let's just click on this tick, and soon we'll have our measure, and we do have it. I'm just going to select this as well. Alright, so now you can see that in 2011, in the sales last year, it's giving the sales for the year 2010, that is the last year, and so on and so forth. And you can also view this according to the quarters. Let me just expand this. Alright, so you see that quarter 1 has the same sales as quarter 1 2011 in the sales last year column. So that is how you use same period last year in the time analysis function.